Okay, so to begin with today, it is a review, which makes you think, oh, this will be easy. No, we take arithmetic and geometric sequences to a whole new level today. So, to begin with, I want to remind you a little bit of where we have been, so get some blank space. And if I gave you 2, 4, 6, that's, I can tell after I got that third term that I for sure was adding each time. You know what I mean? Like, I couldn't tell after just the second term whether that was multiply, which would have been geometric, or adding, which is, what's that called? Arithmetic. All right. Now that I know it's arithmetic, could you please write me something like this between 1 and, let's just stop it at those 3 terms. So from 1 to 3. That is not the right answer. That answer would give me, when I stick in 1, I'd get 3 minus 5 is negative 2. And I stick in 2, it would give me 4 minus 5 is negative 1. And if I stick in 3, it would be 6 minus 5, which is positive 1. I think I messed up on 2. No, I guess that's right. All right. And if I put, yeah, there we go. I would get these 3 terms. So that's not the right answer. There it is. I couldn't figure out what was wrong. That's a negative 3. Sorry. Okay, so would you please write the right equation for these 3 terms? And once you see it, you'll be like, oh, I guess that was actually pretty easy. Who's got it? Raise your hand if you know what we should have in the little parenthesis. Miss L.
2n.
Just 2n. From n equals 1 to 3. You're right. Now, if you didn't get that, you need to learn how to write those. All right, I'm going to give you one more opportunity, but let's just make sure you understand why that actually works. When I put in 1, I put in a 1, and I get 2. When I put in the next number between 1 and 3, which would be 2, I get 4. And when I put in the last number, 3, I get the last term, which was 6. There, it reproduced the original numbers. All right, so let's do something like that. 6, 10, 14. Would you please write a nice little formula for me that would generate that set of 3 terms? I would always go from 1 to however many terms you want. In this case, I have 3 terms, so from 1 to 3. What do you think it is?
4n plus 2.
4n plus 2. Now, if we assume that she's done it right, what should I be able to do to check it? Plug in the 1. And I get 4 plus 2 is 6. Yay. Is there another way you could have done this? It would look very different, but it would be the same. Did anybody get a different answer that they know works? All right. I'm just trying to say, for example, if you had factored that and put 2 goes into both of those, right? So then this would be 2n plus 1. I'm not saying it's better, just saying it would also work. All right. Now, what if it was geometric? Let's do one where it's geometric. 2, and then times 4 is 8, and then times 4 is 32. Now, hint, you're not going to want to do this the same way. You might want to do this with the r and to a power. You can still do from n equals 1 to 3. I see a lot of blank paper, so if you're in that group, it's okay, but think of it as a challenge. You just have to get, when you stick 1 in, it needs to give you a 2. But when you stick in 2, it needs to give you 8. That's a little more of a challenge. How about this? Some ways to think this through. Would you guys agree that that divided by that gives me 4 and that's important? 4 is the common, what's that called? Common ratio. In the formulas we used before, what did we call that? R. So R is 4. Do you remember that the other formula had the R to a power? So has anybody got this one? You think anybody got this? It's only one person. I'm proud of you, one person. Nice work. It shows you how hard this is if only one kid out of a room full of really smart kids gets this. How about if I put it as 4 to a power? Is that in your answer? Assume you had to start with that. 4, and there's got to be a power involved. There could be something added or subtracted. There could be something multiplied at the beginning. Or it could be something like, 2n minus 1 in the power or something like that. Play with it. See if we can get it. I was just hoping we could get it up to like 4 people. Raise your hand if you think you might have it now. All right, nice job. We got a couple more people. All right. So, Mr. H, what do you think you have got that works?
I said 2 times 4 to the n.
All right. Now let's put that together. This almost looks like an exponential where you have a starting term and then something to a power. That's an exponential, right? You started with 2. That would make some sense. And then you multiplied by 4 this many times. Ooh, that seems like it's going to work. Prove to me that it works. Like if I'm your friend and you're saying it works and I'm like, that doesn't work.
So if you plug in 1 for n, it's like the first term.
I put in a 1 right there.
2 times 4 to the 1 minus 1, which is 0.
Ooh,
So
sneaky.
4 to the 0 is 1.
So when you put in a 1 here, it gave you a 4 to the 0, which is a 1, times the 2, which is a 2, and it came out with a 2 as your first term. Well, just because you got 2 doesn't mean that this is right.
Right.
Give me another one.
So if you do 2 for the second term,
So n equals 2 along the way. You stick in a 2 here, and you get
2 to the 4.
it's 4. I think you mean 4 to the 4 to the first, and then you times by 2, which makes 8. Looks like it's working. How do I check the last term? Plug in a 3. 3 minus 1 is 2. 4 squared is 16 times 2, 32. It definitely worked. How could you have replicated that if this was a test and you weren't one of the 2 kids or 3 kids at the end who were raising their hand? How could you have done it? Do you get that you could start with this? You could put it as that's the R. Everybody probably, well, I know we talked about this at the beginning, so you knew there's a 4 involved. And then there has to be a power involved to say how many times you're going to multiply by 4. All right. Okay, so that's kind of where we were. And then we had a couple really formulas. Everybody get to this purple page. Important formulas to consider. The formula for finding the next term. I'm going to give you the example. You tell me what formula would do this. 2 comma add 3 is 5 comma add 3 is 8 dot dot dot. So it's adding 3 each time. What if I said I want the 23rd term? It was a sub n was equal to, let's see if you remember that formula. If you wanted the 23rd term, you know you'd stick 23 into what formula? You may have forgotten this one over the weekend. I would understand that. I'll give you a hint. It starts with a sub 0 plus, it's obviously going to be more because you're adding 3 each time, which is the common difference. So we put D for common difference. And then who remembers the rest of the formula? Say it if you know it. N minus 1. Okay, good. Okay, cool. That's the formula. Now everybody use that formula to figure out the 23rd term. Don't you know A? All right. So A sub 23, 23rd term, would be a 2 plus the common difference of 3 times n minus 1, which is 23 minus 1, which is 22. 22 times 3 is 20, 40, 60. But times 3, I think that's, isn't 20, 66, yep, plus 2 more. Is it 68? Have I got it?
Yeah.
All right. A sub 23, 68. Okay. That's one of your 2 formulas. You've only got 2 so far. And I've talked about, and I'm going to remind you about the kind where you add them up, but you aren't really responsible for that yet. We'll get there. I started the unit with that to kind of give you the big overview thing. The second formula is the one for geometric. Yeah, question? Okay, so here's the geometric one. Imagine for a moment that you add a sequence that's going 2 times 3 is 6, times 3 is 18, dot, dot, dot. A sub n, if it's geometric, try to remember this one. It involves the starting number, and it involves the r. Now this is really important. How do we find r? I know you know this one is 3, but isn't that because it was 6 divided by 2? Why does that matter so much? Because in a minute, the problem's going to be more like this. 6n plus 3, and then 12n minus 9 is the second term, dot, dot, dot. How are you supposed to figure out what you just multiplied by to get that? You take this divided by that. That's how you find the common ratio. So it's easy right now, 6 divided by 2. Just remember what you're actually doing is taking the second term divided by the first term. So in this case, if the problem was more complicated like this, then the common ratio would have been r equals 12n minus 9 over 6n plus 3. And if you can factor it, you should. Sometimes things cancel, and in this case they wouldn't because I have a minus here and a plus there, so they're not going to... Actually, something can cancel. Yeah, there's a 3 in there, and there's a 3 in all of those, so 3 can cancel out of the top and the bottom. So that would be smart. I'll just finish that. So 3 comes out, and I have 4n minus 3 over 3 comes out, and I have 2n plus 1. And so the 3's cancel. It was that common ratio. That's how it gets more complicated. They aren't just numbers anymore, they're variable terms. Okay, so back up to this one. I hope you remember this formula was, it involves r, and it involves a power, and what else does it involve? A, which was the starting term. So this is a lot like what the 1 or 2 kids that figured out the problem a minute ago did. Start with your starting amount, you times by r to the, do you remember it? N minus 1. So now, if I asked you to find the fifth term, I totally get you could do that by just multiplying this by 3 a couple times. Don't. Use this formula. You got to get good at the formulas because that's the only way you're going to solve the problems on the test. You're not going to be able to just game it by sticking them in your head. Okay? All right, so if I'm going to use the formula to find the fifth term, it's a sub 5 is a sub 0, which was 2, times the r, which was 4. No, it's not 4. It's 3. To the power of 5 minus 1. So that's 3 to the 4th. How am I supposed to do that? It's really not that bad. If you write out 3 to the 4th, you'll go, oh, it's 9 times 9. It's 81. That wasn't that bad. 81 times 2? 162. Okay, so that's the other big formula. For those of you that like to keep your notes organized, which is awesome, you should say a sub n is a sub 0 plus, nope, not plus, times, sorry, times r to the n minus 1. All right, what's another important formula to consider? I'm going to remind you because we did this yesterday, but it's so easy to forget. If I wanted to add up the numbers from 1 to 100, do you remember what little Friedrich Gauss was able to figure out? Friedrich. I tell you the story about the little German kid who they were trying to keep him busy, so I said add up the numbers from 1 to 100. Did I tell you that story yesterday or Friday? Okay. So if little Friedrich were told he's this little super smart German kid, that reminds me a little bit of there's a 9-year-old right now who's going on to get get his PhD. 9-year-old in electrical engineering. You're 9. Just for perspective, a lot of kids don't start school till they're 6. So in school 3 years working on the PhD. Holy cow. And not just in like, well, I don't want to diss any particular areas, but there are some areas that are a lot easier to get your PhD. Electrical engineering is not one of them. I think they're going for, why not, also like biomedical at the same time. So anyway.
Where does this person
I think they're from the Netherlands. So I am not certain. We have smart little kids here too. Maybe not that smart, but one of the smartest ever, second smartest recorded IQ. The little kid was from, let me think, Ireland. And he's the basis for the TV show Scorpion. You guys ever heard of that show?
Yeah.
Okay. It's a TV show, and I know there's so many TV shows nowadays that, not many people probably watch it, but it's a true story in that they found this little kid because he hacked the Defense Department website at like age 9. Other kids are just like figuring out how to tie their shoes.
How do you get that smart at age 9?
You get born incredibly smart, and then you learn incredibly fast, and then, anyway, it's hard to comprehend for normal people like us. Nobody in here is that smart. I have smart people in here, but... All right, so little Friedrich took and was told to add up the numbers from 1 to 100, and he, they just did it to try to keep him busy. I mean, realistically, because they figured they'd go 1 plus 2 is 3, plus 3 is 6, and then plus the 4 you see what I'm saying? They expected him to do it that way. But you can tell by what I wrote on the board, what did he actually do? 101. And he did 101, and then he realized, oh, it's a whole bunch of 101s. How many 101s? 50. 50 101s. And what's that? You probably could do that in your head. Well, 50 times the 100 would be 5,000. So what is it? No, that's pretty smart for a little kid. And that way it works to add up any string of numbers. You take the first one plus the last one, and you multiply by how many little combos there are. Let's do one that's short but understandable. 6, comma 8, comma 10, comma 12. Do that first plus the last method. What do they add up to? What's the first plus the last add up to? And the middle ones? So it's 18 times 2, but then how did we really get that 2?
Because there's two.
What I'm trying to say is, what if there's 106 numbers that you have to add up? Divide it by 2. So in this case, there was 4 numbers to add up, so we divided by 2. So I'm going to put a 4 divided by 2 just to show you this pattern a little bit better. It was 4 divided by 2. How many numbers there were? Divided by 2. And then the first plus the last, which was 6 plus 12. So first plus last, and then how many numbers there were divided by 2. That's what he did. And that's what we could do here. 18 times 2, 36. That actually adds to 36. All right, let's see if you really got that. One more. 5, 10, 15, 20, 25, 30. Add those up. Got it yet? Are you using the number 35? So it's how many numbers there were, which was 6 divided by 2, and then it was the first number plus the last number. So 35 times 3. And then I like to do it this way. 3 times, sorry, messed up a parenthesis there. 3 times 30 plus 5. That way I can kind of distribute it. 90 plus 15, what is it? That's what this adds up to. All right. There are formulas that are more complicated than this one, but I'm going to give you this one to put on your list. Put it in the spot number 3 here. It'd be n over 2, n is how many numbers there were, times, what do you think the first number should be called? Considering how we called them on the other ones, a sub 0, plus, what do you think the last number should be called? It's a sub n, but we can replace that with all of this, see? Which is a sub 0 plus d times n minus 1. Now that is a nasty formula to have to remember, but if you just remember, it's the first one, which we know is called a sub 0, and the last one, which we know is a sub 0 plus d times n minus 1. If you break it in chunks like that, it's not that bad. It's the first one plus the last one, and then how many there were divided by 2. All right. Now, we're a smidgen ahead, which is cool, because you don't really officially learn this till later. But I know that's a tough one, and so I've already briefly talked about it on Friday. Now I've talked about it thoroughly. Now when I actually teach it to you, that'll be too. So let's get to this one. The terms k plus 4, 5k plus 4, and k plus 20 are in a geometric sequence. So remember me saying that this was going to get more complicated because there's going to be variables in it? All right. This one's particularly gruesome, so I'm going to not do this one quite yet. I need to do a different one, so holding a second. Okay, so I need to go to the side here and show you an easy one. All right. Let's say it's 2 something something 16. We have formulas. They're really, really handy. And I know some of you are just like, well, let me just guess and check until I find it. I think it's 4, 8, 16. Well, that's great, except it's not going to be geometric. So then it's not that. And that seemed like it was made total sense until I told you it's not geometric. Well, then again, I know you could play with it and you could do this in your head, but don't. Because I'm telling you, the ones that we do on the test, you're not going to be able to do them in your head. And when you say, but I did it in my head, I'm going to say, show me your work. And you'll say, I did it in my head. And I'll say, I'm sorry, I can't give you credit for in my head. So, can't just guess and check. Because again, what if this was 2k plus 7 and the end one was 16k minus 32? Don't tell me you did it in your head. Even though you maybe could if you're a little Friedrich, except different country, different time, place. All right. So, here's how you do with a formula so that when we have the hard ones, you'll have to use a formula. What is the formula for this? If I said it's arithmetic, then it's a sub n. Always write the whole formula all the way out from beginning to end. And make the pure form of the formula. Then you can stick the numbers underneath it. Now, would you agree that a sub 0 is 2? So I can put that in for either term. That's just a fact. A sub 0 is 2. It's our first term. Now, what if I wanted to use this 16? Then I'd have to say, then which term are you messing with? The 16 is the what term? So that would be a sub n, and that would be 16. You see what I'm doing here? I'm saying if a sub n is 16, then 16 is the fourth term, then plus, and I don't know what d is, right? But I do know that n minus 1 would be, if it's the fourth term, it'd be 4 minus 1. Do you get how I have an equation that only has d in it? Oh, it's an equation. You guys know how to solve equations. What I find with the ACT a lot of times is kids don't realize they can write an equation. Once they got an equation, it's like, oh, I know how to do that then. Because I know you can all solve that. 16 equals 2 plus 3d. Subtract 2, 14 equals 3d. d must be 14 thirds. That'd be pretty tough to do in your head. Remember, this was not a multiply one. This was not geometric. This was the add kind. If this bothers you, I'll say it as 4 and 2/3. So if you keep adding 4 and 2/3 each time, did I do that right? I think I did. Did it really fast, so making sure. Yep, it works. Okay, so let me do one like that, except this one, I'm not giving you the first term. It really makes it a lot harder if I don't give you the first term. We'll say it's arithmetic still, where you're adding something each time. And don't think that, well, the smallest number I could start with is 0. No, you could start with a negative number. Don't guess and check. You won't be able to do it on the test. I'm still giving you the easy ones. All right. It involves this formula. They didn't give us a sub 0. How are we supposed to do it? They didn't give us a sub 0, and they didn't give us d. That means we're going to have two variables. The only way to solve if you have two variables is to have... Come on, some of the themes from this course. If you have two variables to solve for, then you will need two equations. What if it were three variables you needed to solve for? Then you would need three equations. And it's a systems of equations question then. All right, so give me an equation that uses the 3, Mr. H. An equation that uses the 3. You could do this. Use this equation right here. Just put the 3 in the right spots. And a few other things.
3 is a sub n.
Yep, 3 equals.
A sub 0.
We don't know a sub 0, so we put a sub 0. Do we know d?
No.
So we put d. And then do we know n?
Yeah.
Yes, we do. So 2 minus 1 goes in here. I'm going to put it as 2 minus 1, and we all know that that's 1. That's an equation, but it's got two variables. How do we solve it? Not until we get the other equation. KT, can you tell me the other equation for using the 14?
14 equals a sub 0
14 equals a sub 0 plus
plus
d
parentheses 4 minus
4 minus 1. So if I want to clean these up, the 2 minus 1 is going to turn into a 1, which is just d, 1d. And the 4 minus 1 is going to turn into a 3, so then I'm going to put the 3 right there. How do you solve this? 3 equals a sub 0 plus d, and 14 equals a sub 0 plus 3d. I want to remind you of a really good way to solve equations that are systems of equations that a lot of you guys just kind of brushed aside. You all know how to do substitution, and I know some of you are like solving for a sub 0 by subtracting d. You're not wrong, but there's a faster way. Make all of the ones on the bottom negative. I just multiplied everything in that equation by negative 1. Then these two will cancel. These two make negative 11. And these two make 2d. Not dd. Oops. 2d. Negative 2d, just like I said. And then divide by negative 2. And you have 11 halves, aka 5.5. But wait, there's more. You now know the common difference is 5.5, but you need to figure out what that is. Now, can I do that in my head? Sure, I can. Could I do it with an equation? Either way. I'm okay with either way on this one. Now that I know it's as simple as I'm going to add 5.5 each time, do you got to just subtract 5.5 then? So then that's negative what? And just to double check, I'm going to go back and add 5.5 to it and see if I really get 3. And I do. And then I'll add 5.5 to that. And that'd be 8.5. And then I'd add 5.5 to that. And it makes 9 and 5 is 14. Yep, it worked. Yay. Yes?
Can you find D a different way? Because I found it a different way originally. But that wasn't guess and check.
Yes, as long as you show your work. Can you tell me? Imagine I'm back at the original problem here. That was all the black. Pretty much it was just that, other than I told you it was arithmetic. What did you do?
I made 3 the starting value, and I made 14 the third term.
Interesting. So you just shifted it in your head to the
Yeah.
that's the first and the third term.
And so then I just did 14 equals 3 plus D, parentheses 3 minus 1.
As long as there's not a flaw, but there's a now you got to factor in when I say what's the first term, you can't say 3.
Yeah, I'd have to.
You'd have to
keep the
adjust for
blanks
that.
in, yeah.
Yes, that's interesting, and I like it. Just be careful with that whole you're off a term, so that you can find the D that way.
But then I have to bring that back to the original.
There you go. Go back to the original when you want to figure out what the first term is. Okay, cool. I'm going to do one more like that, except for where you have an R. That's not arithmetic. Then if you have an R, it's the geometric. All right, so here we go. It starts with I don't know. But then it's 4. Then it's I don't know. Then it's 64. And note, it's not 2 and then 8. Now, don't guess and check it, though. I'm telling you, it's going to be variables such that you won't be able to do that. Okay, I just want to make sure you're good at this before I move to variable mode. If this is geometric, can you please set up the right equation for that 4 and set up the other right equation for the 64? Pausing while we try that one. Okay, we have a student answering, and they said this was the right equation. And I'm just going to ask a question about it. But wait, you have two variables.
Yeah, I wrote another one.
Oh, you wrote another equation. That's what is going to happen. A lot of people are going to be like, "Dude, I can't solve that." Okay, tell me the other equation.
64 equals a sub 0 times r to the 4 minus 1.
All right, I'm going to clean up both of these and put them in red. This one, 4 equals a sub 0 times r. And the other one, 64 equals a sub 0 times r to the third. Now this one's not a good candidate for elimination. This one is going to be better by substitution. Okay, so if I want to take and solve for something, I might as well solve for r. R would be equal to 4 over a sub 0. Then I can put that here. And now I have 64 equals a sub 0 times r, which is 4 over a sub 0, to the third. Now be careful, you cannot cancel this and this. Can't cancel that, because that power has to be done first. So then it's really 4 to the third, which is 64, over a to the 0 to the third, times a sub 0. And then now I can cancel one of those. And this will be a sub 0 squared. A sub 0 squared is equal to 64 over 64, which is equal to 1. So a sub 0 squared is equal to 1. So what's a sub 0 got to be? 1. And it is. And now that you know that it's a 1 there, think about it. You're just timesing by 4. And then timesing by 4 again makes 16. Times by 4 again makes 64. Yay, I figured it out. All right. How could I have figured out r the other way? I could have used these two equations that I had, either one of them, or this one, which is where they came from in the first place. And I could stick in that a sub 0 was 1. And I could put it right here, for example, and I'd know that r equals 4. There it is. Okay, now the last one before we can actually do this assignment is, imagine I have two terms, except they aren't quite so nice anymore. Let's say I start with x. I don't know what the middle term is. By the time I get here, it's 4x plus 8. If this is arithmetic, then I know which equation to use. Set up the two equations that you could set up. Actually, you'd only need one equation. Because I gave you the first term, just use that equation and stick in that for the first term. If you're not getting this yet, you need to know these like the back of your hand. I haven't looked at the back of my hand much lately, but okay. A sub n would be the third term, so it's 4x plus 8 is the third term. The first term is x plus n is the third term. I just messed up my d and my n. If you didn't notice on the board, I apologize. Could have said something. I really want to do that. It's d here, and then n minus 1. Okay, and then I do not know d, the common difference. That's what I'm trying to figure out. And then n minus 1. I do know that this term is the third term, so this is 3 minus 1. So it's 4x plus 8 equals x plus 3 minus 1 is 2, 2d. And wait a minute, I got two variables again. Not really. You just need d, and d has an x in it. I know, there's two variables. But that is the common difference. You're going to add 3x over 2 or 3 halves x or 1.5x plus 4 each time. What's the system? You set up a system of equations. Why did I need 2 equations this time? Because I told you the first one and you could just stick it right in. We knew what the first term was, so we only needed one master equation. We didn't have to go set up 2 equations and then use systems. All right, so we're finally ready. That I think you could actually do this one. It still comes out strange. In the end, they want to know the values of k. Trust the system that we just learned. And hint, that's the second term. That's the first term. That's all you would really need. Hint, one more thing. It's a geometric sequence. Don't by accident use the a sub 0 equals the a sub 0 plus d times n minus 1. This is geometric. So if it's geometric, we got to know this formula. Now I'm going to use the second term. I'm putting parentheses in a key spot, and I hope you do too. A sub 0 was k plus 4. It needs to be in parentheses. R is alone. I solved for R. Is that what they wanted, though? They didn't ask us to solve for R. They want to know what k is. All right, so then we need to get this so that it's only k's in the equation, and then we can solve for k. Do you remember me saying at the beginning of the hour that all we'd have to do is this divided by that to see what the R was? So if we know R is 5k plus 4 over k plus 4, we know that because this divided by this should give us the R. Then, I really don't like this problem, but it's on there, and I thought I better not just go, let's not do it. But it's weird. What's the answer to that?
No.
The answer is not 1. The answer is everything. You are correct.
I don't know why it said 1. I think I thought
As in-
that was a subtract.
It's exactly the same on the left and the right. It would be as if I just said 8 equals 8, and I said, when is that true? And you'd say, well, always? What if I said 8x equals 8x? Isn't that true for any value of x, no matter what I put in? So what's the answer? All reals. I don't like that one. This next one's much better. more normal anyway. But, and it's a big but, you can't do this one yet because you are not good enough at sums of the first three terms. Did you even notice that it didn't say the first and the third term were this? Now, you can do it. Yeah, you can do it. I'm wrong. I was thinking that the only way we could do it is by using that fancy formula I had just explained for the first time today. We don't need that. What's the first term? I don't know. So what do I put for the first term? Don't just put x. Hint, a sub 0 is what we always call the first term. Right?
Mm-hmm.
And what's the third term called? A sub n is equal to a sub 0 plus, if I was going to do the third term, and this is, wait a minute, this is not plus, this is the ratio one, sorry, times r to the n minus 1. And if I'm for sure doing the third term, then couldn't I put in a 3 right here? It's terrible color. There we go. And a sub 0 is still a sub 0, right? And that's the third term. So that right there is the third term. A sub 0 times r to the 3 minus 1, which is 2. That plus that is 40. But wait, Mr. Server, there's two variables. How am I supposed to solve? Because you're going to have two equations. All right, this was the first term. I know you all know that the first term is a sub 0. Do you get how that's the second term? No, the third term, sorry. The third term was this.
Yeah.
All right. So that's the first term plus the third term equals 40. That's not that bad. We've got an equation for that. Now we're going to go get the other one. The second and the fourth terms is 96. Here's the second term. Well, that's like this, except I'm putting in a 2. It's the second term, a sub 2. Well, that would be a sub 0 times r to the 2 minus 1 now I got to add the fourth term plus fourth term would be a sub 0 plus, nope, I keep wanting to say plus there, times r to the, if it's the fourth term, it'd be 4 minus 1. And that's supposed to equal 96. Heavy duty. So this is a sub 0 times r plus a sub 0 times r to the third has to equal 96. How am I supposed to solve that? You have a system of two equations. That equation and that equation. As long as they only have two variables, a sub 0 and r, you can solve them. A lot of people have trouble solving this first one until they realize that they could factor out the a sub 0. Once again, really brutal problem comes down to can factor it? You should. A sub 0 comes out 1 plus r squared equals 40 divided by a sub 0. Nope, sorry, divided by 1 plus r squared. And that's a sub 0. And now I can put that a sub 0 in over here. I know, that was messy. That's why there's only a very small number of problems in tonight's homework. So let's get to those right now. I will get it started with you. I want you to do 4 questions. Get to this one. You're going to think that there's something wrong because number 2 is too easy. It's just that we just did such hard ones that number 2 is actually more normalish. I want you to do 2 and 8. To use the formulas. Just the first 2 pages. 2 and 8 and 10 and 11. And 10 and 11. Remember.
Thank you.
And that's all I have for you for today.